Welcome to the Organic Chemistry Podcast, Dr. Brian Lloyd's scribblecast of organic chemistry lectures and solutions to homework problems. In this solution to a homework problem, you were asked to give the product for the following reaction. The reagents you see over the arrow, sodium ethoxide and bromoform, are known to react to produce carbene. The base, in this case, the ethoxide anion, can grab a proton off the CHBr3. Bromine is sufficiently electronegative to help stabilize the anion that forms. Now granted, this equilibrium will be shifted to the left. There's no doubt about that. Even with the electronegative group stabilizing it, the concentration of alcohol that will form will be small. But you do get some CBr3 anion. Now this anion has good leaving groups. Bromine's a good leaving group, so you will get Dibromocarbene plus Br minus. And the dibromocarbene is our reagent. Now we learned that carbenes add double bonds to make cyclopropanes. So in this reaction, we're going to potentially get two different additions or sites of addition for the dibromocarbene. And we are either going to get it adding on the top double bond, which would give me this product, or it could add to the bottom alkene. If it does, I get this. Now the question is, can you tell who's going to be major in this reaction? And the answer is this alkene. Why is this one major? You might have thought that steric effects would block the carbene's approach, making the left-hand molecule more major. But in actual fact, we learned that alkenes that have electron donating groups, that is, groups that push electrons in, such as through inductive electron donation, increase the electron density in the pi system, making it more susceptible to attack by electrophiles. Because this pi bond with the methyls on it is more electron rich, it is more susceptible to electrophilic attack. The attack of the dibromocarbene at that double bond will occur more often. So there you have it. That is the solution to this problem. I'm Dr. Brian Lloyd. This is my Scribblecast. Thank you very much.